Okay, so with this graphic organizer, this is kind of a good representation of kind of breaking down how you should factor a polynomial. All right. So it's kind of like a step thing where it tells you what you should look for first, what you should look for next, so on and so forth until you're completely factored. Because again, a lot of this unit relies on factoring completely. Okay. Now, with factoring, the very first thing you should always do is check to see if you have a GCF. What does GCF mean? Greatest common factor. So a number or a variable or a value that you can divide into all the terms and it'll come out with a nice even value. All right. And again, it's if possible. There's not always a GCF, but sometimes there is, and it makes your problem a lot easier if you take it out. So for example, let's say I had 2x squared plus 4x plus 6. What do you think my GCF is here? 2. So my GCF would be 2. So if I divide all 3 of these terms by 2, all right, I'll write it here. I get x squared plus 2x plus 3. All right. Now, remember, your GCF isn't always just a number. Sometimes it may be a variable. So for example, let's say I had x cubed plus 2x squared plus 3x. Now what would the GCF be? X. Each of them has at least one x, so we can take an x out. So if we remove an x from x cubed, what is it? X squared. If we remove an x from 2x squared, what is it? 2x. If we remove an x from 3x, what is it? Plus 3. All right. So biggest thing that people forget when they factor out GCF is that GCFs are not just numbers. Sometimes there's a variable thrown into it. So you got to check both. All right. Now, if you factor out a GCF, that's when you kind of get into the split. All right. So your next step depends on the number of terms you have left after you take out the GCF. So depending on the number of terms, that will determine which path you take. All right. So we're just going to go through each of these paths individually. So if you have 2 terms left in the parentheses, so if you look at the parentheses right here, if there's only 2 terms there, you're going to do the following. So the first thing is you're going to check if you have a difference of squares. Okay, so that's typically in the form a squared minus b squared. So in other words, you have 2 perfect squares being subtracted from each other. So an example of that would be 4x squared minus 9. Is 4x squared a perfect square? Is 4 a perfect square? So if I take a square root of 4, it'll give me a nice number. Yes or no? Yes. Is 9 a perfect square? Yes. Is x squared a perfect square? Yes. So if I took a square root of all of these, all right, we would get perfect squares. So the square root of 4x squared is what? What's the square root of 4? 2. What's the square root of x squared? X. So with x squareds, all you do is just divide the exponent by 2. That's your square root. What's the square root of 9? 3. So that's what you would do with the difference of squares. So if you have a difference of squares, so yes, you have a difference of squares, you're going to put in the form a plus b times a minus b. So in other words, you take the square root of both terms like we just did. Then you take those 2 numbers and you separate one of them by a plus and one of them by a minus. That's all you got to do. So 4x squared minus 9 would factor to 2x plus 3 times 2x minus 3. Then you would double check to make sure your factors don't have any more GCS or difference of squares. If not, then you're done. All right. Now, if it's not a difference of squares, meaning you're not subtracting two perfect squares, you want to check to see if it's a sum or difference of cubes, meaning you have two perfect cubes. So it's basically a number cubed or a value cubed. And you're either adding or subtracting them to each other. So very quickly, turn on the back page. Or before you do that. So an example of that would be x cubed plus 8, x cubed minus 8. First one's a sum of cubes, second one's a difference of cubes. Now, to check to see if they're perfect cubes, that means if you take a cube root of both of these, you would get a nice value. So, what do you guys think the cube root of x cubed is? X. So the trick is that if you're taking a cube root, you're dividing your exponent by 3. So if your exponent's a multiple of 3, it has a perfect cube. So this would be x. What about 8? 2. So 2 cubed is 8. So the cube root of 8 is 2. And it'll be the same thing here, x and 2. Now, do not include the negative. All right, so for both difference of squares and difference of cubes, do not include the negative in your roots. All right, just don't do it. You don't need it. Now, what you'll do once you discover if it's a different of cubes, that's where the back comes in. So, if it's a sum of cubes, meaning it's a cubed plus b cubed, so that was our x cubed plus 8. You would find your a and b, meaning you take the cube root, which we already did. So a and b, a is equal to x, b is equal to 2. All right. Then you would take your a and b values and put it into this formula. So the first part is you would do your a value plus your b value, so x plus 2. Then you would square your a value, so x squared is just x squared. Then you will multiply your a and b value, so you do 2 times x, so that's 2x, and they want it separated by a minus. And then you would add whatever your b value is squared. So what's 2 squared? 4. And now that's factored. Now, difference of cubes is very, very similar. It's just a matter of different signs. So if you have a difference of cubes, all right? Difference of cubes. So that's my x cubed minus 8. Same thing. A and b are still x and 2. But now we're going to put it into this formula. Now, if you notice, it's very similar to the sum of cubes, but the difference is that 2 the sign switch. That's the main difference. So this would be your a minus your b value, so x minus 2, times your a value squared, so that's x squared, plus your a times b, so 2 times x is 2x, plus your b value squared, so that's 4. Now it's factored. So how do you remember it? Well, if you're starting with the sum of cubes, that means your first factor will be separated by a plus. And then the first sign, since you're doing a plus first, you then go minus. All right? So your first sign and your second sign between your two factors need to be opposites of each other. So first sign's got to be a plus, then the next sign has to be a minus. The last sign is always a plus. So this sign is always a plus. That's true for both. They're always plus. Now, with the difference of cubes, same thing. If it starts with a minus, that means you start with a minus. That means your second sign that you run into should be the opposite, which is a plus. And then your last sign's always a plus. Okay? So that is what you do if you have two terms. All right? So go back to the front. Now, let's talk about what you would do if you have three terms. So that's what up here is. These are three terms. All right? Now, with three terms, there's two different variations of this. There is where your A value is greater than 1 and your A value is equal to 1. And what I mean by A value, I mean typically you will be in the form AX squared plus BX plus C. So remember when we did quadratic formula and we always had to do, the AX squared plus BX plus C? That's what I mean. Your A value is always the one connected to the X squared. So if your A value is 1, meaning there's nothing in front of the X squared, it's blank, you'll use the factoring shortcut, which we'll talk about in just a second. If your A value is greater than 1, so if it's like a 2, if it's like a -3 or like a 4, whatever, all right, you'll factor either using the AC method or you can use reverse box or you can use the snowflake method. Now, if you don't know what some of these methods are, I'm going to show you all three of them. And then it's a matter of pick whichever one you like the best. All right. Because to be honest, the A is greater than 1. That's kind of the hardest method for factoring. Not really the hardest method. It's just tricky. So I have like 3 different methods that I teach students because usually one method works better for one student than another method works better for another student. All right. So I give you guys options on how you can do it. It's just not one straight path. All right. So after you factor that, again, you check for GCFs and see if you have any difference of squares in your factors, and then you're done. The last one is if you have 4 terms. That's an automatic factoring by grouping, and we'll go through that in a little bit, but that's the only method you can use is factoring by grouping. Now, a big note right here is if we have an equation, meaning if you see an equal sign, so if you have like x squared plus 3x plus 2 equals 0, you would factor it first, then set both factors equal to 0 and solve. All right. So after you factor, you'd set equal to 0 and solve. So if you see an equal sign, you automatically have to solve it. All right. Okay, so now let's do some examples together because that's like just a lot of information I just threw at you. Let's actually put it into practice. Okay. So look at the back side. There's 4 different examples. Number 1 is a difference of squares. So this one, they already told us that's going to be a difference of squares. All right, that's the method that at some point during this factoring, we're going to use. First things first, we got to ask ourselves, do I have a difference of squares currently? So are 8 and 18 perfect squares? Yes or no? What do you think? So if I took a square root of 8 and 18, I get nice numbers, not weird decimals. No, they're not. But I can make them into perfect squares. How? What's the first thing you always got to do when you factor? So on your flow chart, what's the first thing it says to do? Find a A GCF, thank you. So I need to find a GCF and divide it out, which this one does have a GCF. What is that GCF? So 2. So I can divide both these terms by 2 and get nice, pretty numbers or values or whatever. So I'm going to write 2 on the outside. What's 8x to the 4th divided by 2? So what's 8 divided by 2? Right. 8 divided by 2 is 4, and then you just bring down the x to the 4th. What's negative 18 divided by 2? So this will be negative 9y squared. So now that we factored out GCF, is this a difference of squares? Yes. So if I took the square root of both of these, I would get nice, pretty values. So we're going to take that square root and we're going to put it in the form a plus b, a minus b. But first we got to figure out what our a and b's are. So what would a be equal to? Let's go Jackson. So what's the square root of 4? 2. What's the square root of x to the 4th? So if I take the square root of x to the 4th, x squared, good. So what you would do is that if your exponent's even, it's automatically a perfect square. All you got to do is just divide it by 2. So divide whatever the exponent is by 2. That's your new exponent for the square root. All right, what would my b value be? Let's go. Frederick. 3y. Good. Now that we got our a and b, we can just put it back into this formula. So this will be 2x squared plus 3y, 2x squared minus 3y. Now, before I claim that we're done, let's double check and make sure that I don't have any more difference of squares or any GCFs. So is there any more difference of squares? So if I take the square root of either of those terms, they will both give me nice numbers. Is that true? No. Square root 2 is automatically ugly. Square root of 3 is automatically ugly. All right, so we don't have any more difference of squares. Do I have any more GCFs? No. So we're done. So this is our answer if we divide it out. All right. Any questions on difference of squares? So in my opinion, difference of squares is one of the easiest ones you ever had to factor. But just because it looks like it's 2 terms and it's a minus does not mean it is a difference of squares. You got to check to make sure that after you take a GCF out, if there is one, that both of your terms are perfect squares. Every part is perfect squares. All right, the next part. All right, now one thing I forgot to mention about your 3 terms is that you always start with big X. So remember, that's when you have a times c on top, b on the bottom. You're looking for 2 numbers that multiply to give you a times c, add to give you b. So these will be your 2 numbers. So for any 3-term factoring, whether it's a is greater than 1 or a is equal to 1, you always start with big X. All right. So going back to this problem. So now we're doing the shortcut trinomial method. So first things first, because again, my a value is 1 because I got nothing in front of that x squared. So I'm going to start with my big X. So again, I'm putting a times c on top, b on the bottom. So what would a times c be Dylan P? Just the numbers. Yeah, so you'd be using the 1 in front of the x squared and the 18 in front of the y squared. So what's 1 times 18? 18. Good. So if I label this A, B, and C, I only care about my numbers. Just like with quadratic formula, we only care about the numbers. What's my b value? Let's go Jordan. Negative 11. So I need two numbers that multiply to give me 18, but add to give me 11. Now, since we're multiplying to get a positive number, but adding to get a negative number, what does that mean about the signs of both of my numbers? They have to be what? They both got to be negative. So we know that both of our signs got to be negative. So we're just going to go through and list some factors of 18. So someone raise your hand, name me one factor of 18. Wyatt. 9 and what? 2. So 2 and 9. What else? Still an L. 6 and 3. There's one more. What's the obvious one? 18 and 1. Now I can go ahead and make all these negative because we know we have to have both negative. So whoops. All right, so which one of these sets, if I add them together, would give me negative 11? Negative 2, negative 9. So I got negative 9 and negative 2. And guess what? Since we got our factors and our a value is 1, we can go ahead and put them in our factors. So we always start, if the a value is 1, with x in our first factor, x in our second factor. Because x times x is x squared. All right? Then we just write our two numbers immediately after it. So since we have a negative 9, we're going to go minus 9, negative 2, minus 2. And we're done. Now, again, this method only works when a is equal to 1. If a is not equal to 1, do not go straight to your factors after big X. You got to do another step. All right? That's the biggest mistake that a lot of people make. When a is not equal to 1, they try to go straight to the factors after they do big X. You cannot. Any questions on the shortcut method? All right, the next one. So this is our a is greater than 1. So our a value in this case is greater than 1. So we're either going to have to do AC method, reverse box, or the snowflake method. Now, I'm going to show you all three for this problem. The reason I'm showing you all three is so you can decide which one you like. All right? Because like I said, there's more than one way to skin a cat. All right? So it just depends on which one you're most comfortable with and which one you understand the most. Okay, that's what you have to decide. All right, I don't care how you get there as long as you get there. Unless it's with your phone, then no. Or with AI or photo math or whatever. Or your friend. You need to be able to do it on your own. So first things first, we always look for what first besides before we jump right into big X? Whenever we factor, we always start by looking for what? A GCF. Do I have a GCF here? What is it? 2. So I can divide all three of these by 2. So I got a 2 on the outside, and this will be 9x squared minus 13x minus 10. So this will be A, B, and C. Now, just like with the other one, we go into big X. This will give us an idea of what numbers we're using. So remember, A times C is on top, B is on the bottom. So what is A times C, Ryan? So if we multiply the A number and the C number, what is it? Negative 90, good. What's my B value, Caden? Not just 13, negative 13. All right. So now I need two numbers that multiply to give me negative 90, add to give me negative 13. Now, since I'm multiplying to get a negative number, that means one of my numbers has to be what? Not positive, but negative. One of them has to be negative, and one of them has to be positive. But I was shooting for the negative part. So in other words, they're actually going to subtract to give me negative 13. Okay? So let's list factors of 90. Someone raise your hand and tell me a factor of 90. Or a set of factors of 90. Dylan. 45 and 2. What's another one? Someone else. Wyatt. 3 and 30. What else? Dylan. 5 and 18. What else? 1 and 90. And then there's two more. 15 and 6. One more. Already got 3 and 30. Yeah, sorry, that's a bad 30. There's one more. 9 and 10. Now, if I were to subtract these two, so if I'm adding to get a negative number, that means which number has to be negative, the bigger or the smaller? If I want a negative number, the bigger gotta be negative. All right, so one of the bigger numbers gotta be negative. So I'm gonna go ahead and make all my bigger numbers negative. If I add those together, which one would give me negative 13? 5 and negative 18. So I got negative 18 and 5. Now, this is where we branch off into our different methods depending on what you want. Again, I'm going to show you all three methods that I just discussed. All right. So I recommend that you write them down and then you just decide which one you prefer. Okay. So the first one I'm going to do is AC method. So all the AC method is you're going to slap an X on your two factors that you just found. So you always start AC method by doing big X. So all three of these methods start with big X. All right. Then you're going to take these two numbers and we're going to use these two numbers to replace the negative 13x. So we're going to rewrite our trinomial, replacing negative 13x with 5x and negative 18. So this would be 9x squared minus 18x plus 5x minus 10. It doesn't matter what order you wrote them in. I just kind of wrote them how I wrote them. Now, from there, you got to factor by grouping. This is also a factor by grouping review. So you group the first two terms and the last two terms and make sure you include the sign with the third term in your grouping. Now, from each group, we're going to find a GCF. All right. So from the first group, so the 9x squared minus 18x, what's my GCF there? So what did 9 and 18 have in common? What can I divide both of them by? 3. Go higher. 9. What about x and x squared? What can I divide both of them by? X. So my GCF is 9x. So I divide both of these by 9x. I get x minus 2. All right, what about my second group? What does 5x and negative 10 have in common? You can divide both by 5. So if I divide both by 5, I get x minus 2. Now, this is how you know if you did the grouping correctly. If what's left in your parentheses is exactly the same between both groups, you did it correctly. Because what this means is that one of your factors is going to be that shared factor, so x minus 2. Your other factor is going to be if you put your two GCFs together. So you combine those like terms. So it'd be 9x plus 5. Now, What am I missing from my factors? I'm missing something that I may have done already at the top that wasn't necessarily part of this method. What did I do first before I even started like big X or factored anything? You got to bring down the greatest common factor that you pulled out. So we got to bring down that 2. So this would be what it is completely factored. Now, that's with AC method. The next method I'm going to show you is reverse box. Okay, so what all 3 of these methods have in common is you factor out the GCF first, you do big X. All right, that's what all 3 of these methods have in common. Your third step depends on whether you use AC method, reverse box, or snowflake. So the next one I'm going to show you is reverse box. Now, why is it called reverse box? Because we're basically undoing box method. So you know how you multiply 2 polynomials using box method? We're kind of undoing it. So how it works is I have my box. And I'm going to actually fill in the 4 inside boxes with 9x squared minus 13x minus 10, but I'm still going to replace the negative 13x with the negative 18x and the 5x. So if I were doing a box method, what typically goes in the top left box? So this one right here. What typically goes there? What value? Something with a what? X what? Squared. So we're going to put our x squared value here. So this is 9x squared. What typically goes in the bottom right? So this one right here, what type of value typically goes right here? If you just do a normal box method. Just a number, right? Or a constant. So this will be negative 12. So, not negative 12, negative 10. Sorry. So, your top left is always your x squared value. Your bottom right is always your constant. And then your other 2 boxes, that's where you're going to put your negative 18x and your 5x. And it doesn't matter which way you put them. It'll work either way. So I'm going to put the negative 18x here and the 5x here. If I switched them, I would have gotten the exact same answer. It doesn't matter. Now, we're going to undo the box, meaning we're going to find the terms that we multiplied to get the box. So that's why it's called a reverse box. We already have what's inside the box, but now we're working our way out. Okay? So I always tell my students when they do reverse box, start either in the top left or the bottom right. All right, that's your best bet. Now, if you start in the top left, all right, I typically like to start in the top left, but if you're like one that likes to start on the bottom right, you get the same thing. Okay, so I'm going to start on the top left. Now, if I want an x squared, what automatically has to be in both my terms? X's. So that means I got to have an x here and an x here. That'll give me my x squared. Now, the coefficients in front of those x's, that depends. So first, we need to find some factors of 9. What are the factors of 9? 3 and 3 and 1 and 9. Now, this part you don't necessarily need to write down just yet. So what we're about to do, you don't need to write down, but just watch. So you need to test both of those sets of factors to see if it works. And how you tell if it works. So for example, let's say I put 3 here and 3 here. Okay, because 3x times 3x does give me 9x squared. But remember, with box method, your row will multiply to a different column. So for example, if I multiply 3x by some number here, could I come up with a number that's not a fraction that gives me negative 18x if I multiply it to 3x? Yes. Okay, so that works. But if I go here, if I multiply 3x to some number, Is there any number that's not a fraction that would give me 5x? No. Since that doesn't work, 3x is not our option. So that means we're probably using the 1 and the 9. Okay? Now, it's just a matter of figuring out where the heck the 9 goes. All right? Because the 1, we know 1s, we can multiply anything to 1, it gets itself. Okay? But we got to figure out where the 9 goes. So let's say I put the 9 here. So if I put the 9 up top, is there anything I can multiply to this 9x to give me 5x? That's not a fraction. Yes or no? No. What about if I put the 9x here? Can I multiply anything to the 9x to give me negative 18x? Yes. What is it? Negative 2, and that's what I'll put up here. Then, x times what number gives me 5x? 5. And guess what? Here's your factors. So if I write out my factors, including my GCF, I get the exact same thing that we got with the AC method. So some people like reverse box method because it's a bit more organized. It's a little less algebraic. It's more of a guess and check kind of method, a little bit. But it's more so, there's more logic into it than just, the algebra. All right, the last method I'm going to show you is snowflake method. Now, snowflake method is kind of like big X, but it's like a one and done. So you only got to do one snowflake, and you don't have to do the big X beforehand. Okay? Heads up, guys. Come on, we're almost done. And then we're going to play a game. There may be candy and stickers on the line. So, snowflake. I'm literally going to draw a kindergarten version of a snowflake. All right, so it's a big X with another line through it. Star, snowflake, whatever. Yeah, we ain't going with an asterisk. Kindergarten ain't going to know what an asterisk is. So, same thing. We still got A times C on the top. We still got B on the bottom. We're still finding two numbers that multiply to A times C, add to B. But those numbers we're going to put here. So, in the bottom part of our left and right side. The top part, we're going to put our A value and then slap an X on it for both sides of the top part. So we already did the big X, so I can just fill this part in. So this will be negative 90. This will be negative 13. And we already found that negative 18 and positive 5 work. We already did that part, so I can just fill that in. Now, what's my A value up top? So what's my original A value? Not 18, talking about after we took the GCF out. So up here, what's my A value? 9. So I'm just going to write 9x. All right, so you want the A value times x. Now, why we wrote an x after it? Because this next step will give us our factors. Because if you look here, we have two fractions. We have 9x over negative 18, and we have 9x over 5. This last step is the most crucial to getting your two factors because you have to simplify your fractions. If they can. If they don't, then it's fine. So, 9x and negative 18, can I simplify that? Yes or no? Yeah. What can I divide both the top and the bottom by? 3 and 9. All right. So if I divide by 9, I get x over negative 2. Leave it like that for right now. Can I divide 9x and 5? No. So it's equal to itself. And then guess what? If you write out these factors horizontally, these are your two factors. So if you write them out horizontally, this will be x minus 2 times 9x plus 5, because you always keep the signs that's in front of it. Then you slap the 2 on, you still get this exact same thing that we came up with here. So the biggest mistake that I see people make with Snowflake is they forget to simplify the fractions at the end. Okay, if you don't simplify the fraction, your answer is going to be jacked up. Also, guys, take a minute and guess and check. So your first term should be 9x squared. So if you do your first, like if you do a quick FOIL, you just have to do the F part really. If you do x times 9x, that gives you 9x squared. Well, let's say I didn't simplify these. What's 9x times 9x? Nope. 9x times 9x. 81x squared. So that should be your clue in that you did something wrong. It doesn't match what you started with. All right? So take a minute and just double check. All right, this last one's really, really quick because we already did a sum of cubes, so this one we'll go through quickly. So remember, sum of cubes, you're going to put in the formula a plus b times a squared minus ab plus b squared. But we got to find a and b first. So both of these are already perfect cubes, so I'm just going to take the cube root of both. So a and b. What's the cube root of 8? 2. What's the cube root of x cubed? Just x. How you figure that out? If you divide the exponent by 3, that's your new exponent after you take the cube root. So if your exponent's a multiple by 3, it's automatically a perfect cube. What's the cube root of 27? 3. So those are my two values, and I just got to put it back into the formula. So I have a plus b, so I have 2x plus 3. I then have to square 2x, so you got to square both pieces of 2x. So what's 2 squared? 4. What's x squared? X squared. Then I multiply 2x and 3. I put it in front of a minus sign. So what's 2x times 3? 6x. And then I square my b value. So what's the square of 3? 9. And I'm done. That's it. All right. Any questions on this? So for the rest of class, what we're going to do is we're going to do some factoring practice. And by that, I mean we're going to play a game. What? Okay, guys, take a 5-minute break. I want your butts back in here by 12:25. Really? No, now we're doing factoring practice. We're about to start again. We're on 5-minute break right now. You use that question. Uh-huh. Were you outside for a bit? Maybe. Yes. At least we got a baby. What did I get at base? Base garage. 65. Leslie, can we join Zach's recruiting?
Play a game.
I got Alright, so.
I can't even give you.
Alright, y'all want a cow, a rooster, a dog, a pig, a donkey, a sheep, or a duck? So y'all want pig, cow, rooster, dog, or duck? Okay, do y'all want a rooster, a cow, a sheep, or cow?
I think we might want to trade out the power.
Y'all want a rooster, a sheep, No.
Sounds like you can.
No. All right, get out your system now. Just when I say so. We're not gonna bring it.
We don't want this one anymore.
We gotta choose the big list.
No.
I also got a donkey. I love this dumb dog. I should get one of these. All right.
Why don't you get longer?
And done. All right, listen. All right, no more buzzing. Not out of your system. Don't hit it again. Okay. So, what we're going to do is you're going to need the factoring review packets. It's the smaller packet that says factoring review problems. So, this is how it's going to work. We're going to kind of do a relay of sorts. All right? So it's not a matter of who gets it right first, it's who gets the most right in the most amount of time. All right? So there is big stickers and candy on the line. All right? So here's how it's going to work. I'm going to give you all the same problem to start off with. All right? You're going to work it together as your group. When you have an answer, you're going to go to your whiteboard and write only the answer, not the word. Once you have the answer up, you're going to hit your buzzer, and that'll tell me to go check. All right? If I tell you you're right, and I am going to check your work, okay? If I tell you you're right, I'll give you the next problem. All right? If I tell you you're wrong, you have to rework it until you get it right. Every one you get right, you get 1 point. The person with the most, or the team with the most points at the end, will either get stickers or candy on the chest stick. Okay? So So again, like you can't just look off of someone else's board that got it right and write that answer. I will be checking work. Okay. And the same person cannot always show me work. It's going to be a different person every time. So you guys better make sure that you're responsible for trying all the problems. Okay, so y'all ready?
No.
All right, so I got Team Rooster. I got Team Pig. I got Team Donkey. I got Team Duck. And I got Team Cow.
That wasn't me.
All right, so if I hear the buzzer anymore, that means I'm coming to check your answer. All right. So your buzzer is just to tell me that you're done with the current problem that you're on. Okay, so y'all ready? Everyone's going to start on the same problem. Now, we're not going to do the exact board, so let's do this. This group, board 2. This group, board 1. That group, board 4. This group, board 7. That group, board 5. Okay? And just for today. Just for today. Okay, so your first problem is the anticipation. Let's start y'all off easy. Number 4. So number 4 on your factoring packet. So talk with your group mates, work together. Remember, once you guys get an answer, go right on your board, hit your buzzer. Yes.
Oh, wait.
So talk with your group mates, discuss. Look at your flow chart. Think about what you have to use for it. Work. Good. Yeah. Well, what's reality? Which one do you want to use? The easy one.
Did we just write the answer?
The first letter, and then whatever sign is with your numbers, that's your answer.
Right?
So each one starts by M, and then plus or minus whatever numbers.
Do not write the answer.
So you got
No,
eight,
because then everybody's going to copy this one. They're all going to get it right. Yes, it is.
Work. Good. 10.
Yeah, right.
I don't know. You bring the
No, you're already buzzing.
Good. 10. Good. 10.
I noticed it.
Write it down. But that makes sense.
She doesn't want people calling it 10. Because it's like, all right, so everyone's on the board. You English. I'll work on number 10 now. So it's two terms.
Right.
So you automatically look for what? What's your flow chart say for the four terms? But before you cube, you look for. So are both of these perfect squares? So that's what you use.
Okay.
Well, not always gonna get very well, we were squares. So if you take a square.
Oh, that's where. X. Wait, why would it be X minus 7? Miss Murphy, I can help with it.
What's your A value?
So it's 7 minus X?
So you always write in the order of the terms.
So right on the board.
Not divide. I'll be right there. Keep your pants on.
What?
Oh,
False alarm.
good, except.
No.
One brother.
I want you guys to do 14.
You're the one.
You have to write it.
It's all my work so used.
Yep, 14. Square root of X squared.
No,
Then also you're working backwards. You gotta write the original.
the shortcut trinomial one? No. I don't want to do this one. We just choose that. I know, but I don't want to do that.
Okay. First you're working backwards. I'll give it to you. I'll give it to you. So just know that you always write X on the end of the
Yeah, same thing with
in the order. So we're answering yes. All right, 14. I said I was going to know that you got sign here. Alright. So you got a sign error. I know that's 6. You got a sign error. They're both negatives. You have a sign error. One of your sides is wrong.
What would it be now?
Alright. Good, 20.
They just coming back here too?